Hello, Eric Bryan Cosplay here. I'm going to show you what really happens when I start to prototype something, especially something complex like levers. I usually start with like Legos because they're great, they're flexible, you can make pivoty things, all sorts of good stuff. You can change things relatively easily without investing too much in the design. So this is a prototype for Yellowjacket's arms. If you recall, I'll have to maybe put up a picture later, but if you can just see the arms on the back of him, he's got a black piece, a yellow piece in the middle, and another black piece. So to cut down on needing expensive actuators and servos and whatnot, you can see this forms a U. I'd have to have one here and one here. Well, by making these little cross arms here, these other levers, I can get away with only having one. One of these arms will operate both. So by having one, I can do twice as much work with half as many parts. So with that in mind, this is what it's like with a carbon fiber tube and my 3D printed prototype here. Now these parts are hollow, so they're not super sturdy, but they are sturdy enough so I can kind of mock up what it's going to look like. So this right here is that arm, full scale, on some carbon fiber tubes, which are these black things here, and a mock-up of the linear actuator itself. I found a 3D model off of Figuri. Can't remember what their name is. I think they're Italian. Anyway, they make these linear actuators, which are great. These little boxes right here. Linear actuator means linear, actuating meaning you can control it. So because of that, I can now use one thing to push and pull on this little lever right here. So if I kind of take that, so I can push and pull and operate that lever. This is longer than this one, just like in the Legos. Because of that, because this one is shorter, it will push up on the bottom part here. That happens, it goes, oops, and there goes screw. I've got screws loose. No surprise, huh? So that's how that works, just like that. See? And the linear actuator is held in place with these little brackets I made that of course conform to the shape of the real linear actuator. And of course you just put a bolt through there and it keeps it in. This one may or may not be required depending on what I do. If I need to do two, if I need to gang these together, I'll make these brackets a little wider, offset them a little bit so that they're centered over the tube. That way I can actuate this rod and have more force going up here. My next goal is to try and make it so that I can keep all the actuators down here on the base arm, which is the one that comes right out of the backpack and goes up through the segments, through one segment, two segments, and the third one I'll probably put a servo on because it's just a little teeny piece. And if I can come up with something to come off of here or off of one of these other pieces, I can then operate them all the way up the line. So there you go, another little 3D printed prototype. Once I get them done, I'll go from the prototype hollow stuff. By hollow I mean it's what we call infill. You can see this piece right here. This is what's inside most 3D printed pieces. Because if you printed solid, you'd go through a whole pile of plastic. So they kind of cheat and they just infill it with this little grid. It varies from machine to machine, manufacturer to manufacturer, software to software, what the infill looks like. But usually a square grid is the most common. So it's also very light too, which keeps weight down on some pieces. But these pieces, once they're done, will be printed 100% solid. Alright, so there you go. Thanks for watching. Eric Bryan Cosplay on Facebook.com.